Hello, everyone. We are going to go through the metric system today, which we are going to talk about the units, including meters, grams, and liters. So, as we said yesterday, for the first step of a scientific method, we are going to do observations. There are two different type of observations. One is called qualitative observations, which means we use our five senses to observe, and we can smell it, we can see it, and we can see the color. We can say, hey, this piece of paper is in red color, or we can say this pencil is in yellow color, or we can say this food smells good. That's qualitative observations. For another type, it's called quantitative observations, which relates to the quantity, means the numbers. For example, I have five pencils, or this pencil is 3 centimeters long, like that kind of. It sometimes you can estimate it, you can count it, but sometimes we're going to have to measure it. So in the following slides, I'm going to explain how are we going to take the measurements for um, different kinds of observations. Okay, for any measurement, it need to have a number and also a unit. So we're going to focus on the unit part right now. Okay, so in the United States, we are using a system like pounds, no, we don't use grams, pounds, like ounces, um, and miles, and different things, yard, foot, feet, inches. So this is not a standard system, and there are only three countries in the whole world are still using the system we are using right now in the United States. So there's another system, people call it metric system or international system of units, or SI system. Basically, all the other countries are using those systems. So as a scientist, we have to be able to use the metric system because we have to communicate with the world. Okay, so the base unit in the metric system, including meter for length, like the distance, and the cubic meter or liter for volume, and gram for mass, and Celsius for temperature. I'm going to go through each one for detail. You may write this down in your notebook, please. Pause it here and then write those down first. Okay, for length, we can take a measurement with a meter stick, and the unit is meter. Okay, so basically, a meter is about the length of um, the width of the door. Okay, and volume is talking about the amount of space object takes up. If you see a very fat and tall people, you can see he has a big volume. That's because it takes a big space. Okay. So for volume, we use cubic meter, or for solid, or cubic centimeter, and we use milliliter or liter for liquid. When we take a measurement for liquid, we use a graduated cylinder, which look like this. And for solid, a regular solid, we can take a measurement of the length, width, and height, and then um, calculate it. Okay, for mass, it's talking about the amount of matter in the object. And we are going to learn more detail. When we measure the mass, we use a scale to take the measurement. The unit is gram. Okay, for temperature, in other country, like for me, I have been using Celsius the whole time, so I have no idea about Fahrenheit. And temperatures, the unit is Celsius, and how this is defined is the melting point of water. Like the ice melt to water is at 0 Celsius, and the boiling point of water is 100 Celsius, and then they divide by 100 to get each degree. Okay, so there are some prefixes for the unit. Kilo is 1,000, hecto is 100, deca is 10, and the base unit is gram, liter, and meter. And then deci is 0.1, centi is 0.01, milli is 0.001. I'm not going to go through the detail. Please watch the Edpuzzle video for more explanation about these prefixes and how are we going to use them, and take some notes following the Edpuzzle video. Okay, whenever we take a measurement, there are two concepts. One is called accuracy, and the other one is called precision. Accuracy is talking about how accurate your measurement is. Okay, accuracy means how close single measurement comes compared to the true value of what is being measured. So it's talking about how accurate it is, talking about if it's correct. Precision is how close the if normally as a scientist we have to repeat what we measured, right? We have to repeat a few times to figure out if we got the right results. So precision is talking about how close those several measurements are to the same value. Means how close are those measurements. So basically it's talking about if our test results can be reproducible. Okay, this two is different. This one is like compared to the true value. This one is compared to each other. Okay, so here is a picture showing you what does it mean. Okay, so for example, if this is our target, the red dot represent the true value. If we took like 6 measurements and they spread out like this. So we can say they have low accuracy because some values are far away from the true value. And each of one of them are spread out. They are not close to each other. So it also has low precision. Okay, so this one, all 5 measurements, they are close to each other. Means when we compare those 5 values, they're reproducible. So we say this has high precision, but they're all of them are far away from this true value, so we say it has low accuracy. And this one represents the data with high accuracy because all of them kind of fit into the targets. They are like very close to the true value. At the same time, they have high precision because each one of them are like similar as each other. So we call this a good measurement. Okay, all of those are not good. This one probably is because some human error or the instrument, and this one certainly is the instrument has a problem. So it's better to change the instrument to make accurate measurement. So this one is the one we want to have. Okay. So the last thing I want to tell you today is the significant figures during a measurement. Okay, what does it mean by a significant figure? A significant figure is the minimum number of digits required to report a value without loss of accuracy. Okay, we call those number significant figures. Okay, any measurement must always be reported to the correct number of sig figs. It's very important to do this as a scientist. What does it mean? Okay, let's look at 2 examples in here. Okay, for example, I have a ruler. I'm using a ruler to measure this pencil, the length of the pencil. Okay, so in this ruler, the smallest scale is just this is centimeter. It's 1 centimeter, 2 centimeters, 3 centimeters. So the pencil's length is between 6 and 7. I cannot say this pencil is 6 centimeter, or I cannot say it's 7 centimeter. I have to estimate a value in between 6 and 7. So some people may say it's 6.7. Someone may say it's 6.6 centimeter. Okay, you cannot say it's 6.6 or 7, but at the same time, you cannot say it's 6.7895. You know, it's not that accurate. So this instrument has a limitation. So what we do is when we take the measurement, we take one estimate for the smallest scales. Compared to the smallest scales, we estimate one more digit. Okay, this is a picture of a graduate cylinder, part of the graduate cylinder. So here is 35 milliliter. Here is a 40. Let's say this is some water in here. When we take the measurement of the water, it has a curve because it's stick on the glass surface. Um, and what we do is to measure the lowest point. Again, this is 35, this is 40. Between 35 and 40, it has separated to 5 parts. So this is 36, this is 37, 38, 39. When we take this measurement, again, we cannot say it's 36, and also we cannot say it's 37 because those are not accurate. We have to estimate one digit in between of 36 and 37. So it's some people may say 36.5, some may say 36.4 milliliter. Both are correct, okay, because the last digit is the estimate. We must have it. It can be off by a little bit because it depends on the person who married. It depends on our um, like um, like our own estimate. But we have to have this digit. Okay. Again, we cannot say it's 36 milliliter. We also cannot say it's 36.547 milliliter because this instrument is not that accurate, right? So we have to just estimate one digit. We call this has two sig figs. This has three sig figs. Okay, so for sig figs, I'm not going to ask you to do any calculation with it. So just whenever you take a measurement, you have to estimate the last digit. Okay, that's the thing I need you to know. So why we care about sig figs? It's very important in science, but in the real world, like for example, Michael Phelps, he won so many golden medals, but normally the I mean, his speed is just very similar as the other swimmers. He's just like a few, probably milliseconds faster. So that's why we have to be able to measure it very accurately and to estimate the last digit at the same time. Okay, as a scientist, we use lots of, like, for example, we make medicine for people to take. Also, people go to aeros, we do like satellites or some spaceship. Whenever we do those things, we have to take a very accurate measurement and have to include the sig figs. Otherwise, we might make a big mistake. Okay, thank you for watching. It's lots of stuff. We're going to explain more in the live class.